This is question 8. So we have Mr. Singh collected data about the number of students in each of 3 classes in his school and the mean mark of each class in a science test. Okay, so this is the number of students and this is the class mean mark. The table gives information about this data. Okay, so we've got 3 classes. The names are given A, B, and C. We've got the number of students and one is missing, and we have the mean mark for each class. And we have the mean mark for class C, where we don't know how many students there were. Next it says, Mr. Singh plans to use one of the following 2 methods to work out the mean mark of all the students in the 3 classes. So method 1, work out the mean of 63, 72, and 55. So that would mean adding these up and dividing by 3. Method 2, given that Mr. Singh knows the value of n, so he actually knows the value here, it's just not given to us, work out the weighted mean mark for the 3 classes. Okay, so for each of these 2 methods, assess whether or not the method is an appropriate way to work out the mean mark of all the students in the 3 classes. So we want to know a mean mark for all the students in the 3 classes. Okay, so first one, we can see that this is the method, and you can see that this is 28 and this is 32, and this 72 should have a bigger weighting because there's 4 more students here and it's a higher mean mark as well. So this is important. So just finding the mean of these 3 numbers does not take into account the different number of students here. Okay. And method 2 is to work out a weighted mean. Now, weighted mean would use these weightings, okay, or these numbers of students, and do it in proportion. So this 72 will get its true value with those added 4 students more than the 28 and so on. Okay, so here the weighted mean will take into account the different numbers of students. So you say something here. Next question, the weighted mean mark for the 3 classes is 64.1. So this has been given to us, the weighted mean mark, and this is correct to 1 decimal place. Calculate the value of n. So we need to find the value of n. Now we need to work backwards. Now, anytime you need to work backwards, I think it's always useful to write out an equation. Okay. So what you want to do, and this is the same for maths classes as well as statistics as well. Okay, so the weighted mean mark for the 3 classes. Okay, so I'm going to sort of take that, and then 64.1, and the is, I'm going to make it into an equal sign. Okay, so let me just highlight that one instead. So this is going to be an equal sign. So I've got equals. I've got 64.1 on the right side, and on the left-hand side, I need the working out of the weighted mean mark for the 3 classes. So how I would have worked that out. I shouldn't worry about the algebra there. I should just use the algebra and apply my multiplication, addition, and division, all of that to the algebra and the numbers where I can. Okay, so let's see how it goes. So we would have done 63 times 28. We would have also done 72 times 32 and added that, 72 times 32. And we also would have added to that 55 times n. 55 times n is 55n. And then we would have divided all of that by the total weighting. So that would be 28, add 32, add n. Okay? Now, what you need to do now is you can work out a number here. You can work out a number here and add it up. You wouldn't be able to add this to the 55n, so you need to keep it separate like this. 28 add 32 you can do, so that would be 60, so 60 plus n here at the bottom. So 60 plus n will be multiplied to this side, and then you would just rearrange the equation to make n the subject. Okay, so remember, when you do 60 plus n multiplied to this side, you're going to need to do it in a bracket, okay, because there's going to be the 60 and there's going to be the n, and 64.1 will need to multiply to each of those. Okay, so write out this equation and then just solve that equation. Now remember, this is for maths and statistics. Whenever you get something is some value like this, okay, often what you can do is you can make the is into an equals. Whatever you have on that side goes there, and whatever you have on the left side is written in sort of numbers and algebra on this side, okay, and then you just solve that equation. So this is a continuation of question 8. So it reads, the 3 classes have also taken a mathematics test. Mr. Singh thinks that there is a relationship between the science marks and the mathematics marks. Okay. Then he draws a scatter diagram for each of the 3 classes. For each diagram, he used the science mark, which was X, for each student in the class as the explanatory variable, and the corresponding maths mark, M, as the response variable. Okay. So Mr. Singh then used statistical software. Notice also the M is in place of a Y. Okay, so X and M axis. So we're going to have X along here, M going like this. Mr. Singh then used statistical software to find the equation of the regression line, or the equation of the line of best fit, for the data in each scatter diagram. Okay, so here are the equations. And for each class, we have it here. So class A, you got M is equal to, we would have had Y is equal to, so, it really doesn't matter. So M is equal to 1.4x, take away 1. You got the next one, M equals 1.2x plus 5. Let's try and think about what these mean actually. So 1.4, it would be the gradient. -1 would be where it crosses the M axis, or it would have been the vertical axis, which would be in the Y axis, okay? Now, that's where it would cross, but remember, that would be extrapolating to someone that got 0 marks in a science test, okay? And maybe no one got 0 marks in a science test, and, it doesn't really matter. It just tells you, it will be 1.4 gradient, which might be something like this, and how high or low it is, okay? So the -1 is saying it's a 1.4 gradient, and it's not going to be too high. Then you got second one, class B. You got 1.2 gradient, and it's plus 5, so 1.2 gradient and a little bit higher. And C is negative gradient, -1.3, and then a little bit higher. So negative, it will be going like this, and it would be, a little bit above the x-axis. Then we got Mr. Singh thinks that he has made a mistake with one of the equations. Compare the equations of the 3 regression lines and explain which one is most likely to be incorrect. Okay, so explain your answer in context. So we need to interpret as well. So there's 2 things that you might think are a problem. This -1 here and this -1.3. Now, a negative gradient would mean that there's a negative correlation. Remember that. This -1 is just telling you where the line will be. Okay, so that 1.4 gradient, is it here, or is it a little bit lower here, or is it a little bit higher? And remember, so this we don't need to extrapolate, and this -1 means someone that got 0 marks is getting a -1 in maths. Okay, but we don't need to extrapolate that far. So this is okay. The big problem is this one, the negative gradient, and it's different from the other classes, so it's likely to be wrong here. Okay, so it's likely to be wrong here, the -1.3 here. Now, that's what you're going to say. So compare the equation and explain which one is likely to be incorrect. It's going to be this one. And you're going to say also that you have to say in context. So the context is about maths marks and science marks. So think about, okay, is it likely that we would have got negative correlation between them? Again, this is a continuation of question 8, and this reads, Mr. Singh decides to compare the science marks X and the history marks Y, so something different now, of class A. He uses statistical software to draw this scatter diagram and the regression line. So you have it here. Find an equation of the regression line of the scatter graph in the form Y equals A plus BX. So A would be the y-intercept, okay? So you can sort of read it off here, so whatever the value is there. Think about the scale and think about where it's crossing. And B would be the gradient. Now remember, when you're doing gradient, you want to choose points on the line that sort of go through the grid lines. Okay, so if I choose some, so I might choose this point here, and another good one that goes through the grid lines is there. And I just look at what the gradient here is, so difference going up, difference going forward, and I just divide them. And that would be the value of B.